Hi everyone, I'm Seth and I'm going to talk a little bit about this problem that is on our section notes, Seth and Carolyn. It was originally created by Rosenthal in 2008 in a paper that he published, and it's a variant on Monty Hall called the Monty Crawl problem. So like in the original problem, you have three doors, and you can select one door. So without loss of generality, I'm going to say that I'm going to select door 1. And then Monty reveals one non-selected door which does not contain the car. So importantly, Monty's not going to spoil the game. He's always going to open a door that has a goat in it. However, Monty's very tired, so he crawls from his position by door 1. So this is Monty by door 1 to the door that he's going to open. And if he has a choice of doors to open, he's always going to open the smallest number available door. So say that the car is here. That's the only time that he has a choice, because if the car was say in door 2 and I had door 1, then he'd have to open door 3 because he's always going to choose a door that contains a goat. But say that the car is in door 1, this is the only time that he has a choice. He's always going to crawl to the lowest number door, which in this case is door 2. So he's never going to select door 3 if he has a choice. Okay, so now that we have the setup of the problem, the question is, what is our optimal strategy? So the way that I like to solve this problem is kind of by think about what our win conditions are and basing it off of what Monty does. So again, my strategy is the first thing that I want to write out, and it's to choose door 1, but I'm also going to switch. And you could easily solve this problem by looking at stay, but again, the probability that you win if you switch is equal to 1 minus the probability that you win if you stay. So it's pretty analogous. It doesn't really matter what your strategy is. So for concreteness, I'm going to pick switch. Cool. Then I want to talk about what my win conditions are. So what are my win conditions here? Well, I win if, the car is in door 2 and Monty opens door 3, or if the car is in door 3 and Monty opens door 2. So to start off, I'm going to define some events. I'm going to let C1, C2, C3 be the events that the car is in door 1, 2, and 3 respectively. And MI will be that Monty opens door I, where I is in 1, 2, 3. Okay, great. Then, mathematically, what my win conditions are C2, given that M3, and that one goes with this win condition here. And then this other win condition is C3, given M2. So I kind of want to find both of those things. So what I'm going to do is I'm going to find the probability that C2 given M3. And the way that I can do this is I just write out Bayes' rule. So what's the probability that Monty opens door 3 given that the car is in door 2 times the probability that the car is in door 2 divided by the probability that Monty opens door 3. Okay, thinking about the problem hard. If Monty opens door 3, or given that the car is in door 2 and I've selected door 1, Monty's always going to open door 3 because that's the only choice he has. So that's 1. And unconditionally, the cars are equally likely to be in any door. So the hard part here is figuring out what the probability is that Monty opens door 3, which is by LOTP. Which is that by LOTP, right? So I'm just conditioning on where the car is. What's the probability that Monty opens door 3 given that the car is in door 1? Well, remember, if the car is in door 1, Monty's never going to open door 3 because he's crawling to door 2. So that's actually 0. What's the probability that Monty opens door 3 given the car is in door 2? That's 1 because he has to. That's also, these are all still 1/3, right? Because the car is equally likely to be in any position. But the probability that Monty opens door 3 given that the car is in door 2, I picked door 1, car is in door 2. That means that Monty has to open door 3 because it's the only available door that has a goat in it, right? And similarly, here, what's the probability that Monty opens door 3 given that the car is in door 3? It's 0 because he can't spoil the game. So, the probability that Monty opens door 3 is the sum of all of these things, which is just 1/3. So going back to our original equation, this is 1/3 divided by 1/3, which equals 1. So the probability that I win, given that Monty opens door 3, is 1 if I switch. So conditioning on the fact that Monty opens the higher numbered door, and I switch, I always win. But we also have to consider that other win condition, right? So let's do that now. Sorry, that's the probability that the car is in door 3, given that Monty is in opens door 2. We can find this, again, by Bayes' rule, and I'm going to speed through this one this time because it's perfectly analogous to the first one. I'm just going to move that out of the way, so what I'm drawing here, it's a little bit easier. Given that the car is in door 3, Monty has to open door 2. The car is still equally likely to be in any position. M2 is the exact same thing that we wrote out by LOTP. Now we just have to think hard about what this is. So this is very clearly still all 1/3 unconditional probabilities of where the car is. Okay. What's the probability that Monty opens door 2 given that the car is in door 1? Back to our picture. Car is in door 1. Monty has a choice, but Monty crawls to door 2 and opens it up. So that probability is 1. Monty can't spoil the game, so that's still 0. And if Monty doesn't have a choice, he still has to open a door with a goat and not a car. So in total, this probability is 2/3, which means that overall, this is 1/3 divided by 2/3, which is 1/2. So what this tells us is that our strategy for this game is entirely conditioned on what door Monty opens. So if Monty opens door 2, then our probability of winning if we switch is 1/2. And, analogously, the probability that we win if we stay is also 1/2 because it's 1 minus 1/2, right? So if Monty opens door 2, then it doesn't matter if we stay or switch. But if Monty opens door 3, then our optimal strategy is always to switch. Because the probability that the car is in door 2, given that Monty opens door 3, is 1. So if I had to define an optimal strategy for this game, I would say that it's entirely dependent on whether or not Monty opens a high-numbered door or a low-numbered door. If Monty opens the lower-numbered door, my probability of winning if I switch is 1/2. And if Monty opens a high-numbered door, the probability that I win if I switch is 1. Therefore, on a whole, if you forced me to pick a strategy before I saw Monty opening a door, I would definitely pick to switch. And that's the whole problem. So I hope that was helpful, and happy studying.